Example 4, simplify. Okay, again we have fractions here, so let me copy the first one, 3 to the power of n plus 6 to the power of n divided by 3 to the power of n. Now, again, I'm going to apply the strategy of replacing bases by product of convenient prime factors. So the first base here is 3, which is a prime. I leave it without any change. So I just copy 3 to the power of n plus, but number 6 here is 2 times 3. So we can use a product 2 times 3 as a base and raise it to the power of n and divide it by 3 to the power of n again. Now, another step is to use the law ab to the power of n equals a to the power of n times b to the power of n. It's the power law, so let me apply it for this second term in the numerator. So it's 3 to the power of n plus 2 to the power of n times 3 to the power of n divided by 3 to the power of n. Now you can look at the numerator and see that there are two terms, the first one and the second term. Terms are separated by plus or minus sign, so this one thing here is a term and also this is a term. So there are two terms and they have a common factor of 3 to the power of n. So it can be factored out in front, so it's just like 3 to the power of n times, now this 3 to the power of n was 1 times 3 to the power of n. So what is left is 1 plus 2 to the power of n, like this, divided by 3 to the power of n. And this is again 1 times 3 to the power of n. What we can do now, we can identify a common factor between numerator and denominator. They have the common factor of 3 to the power of n, and this can be cancelled. And what you get is 1 plus 2 to the power of n divided by 1, which of course is a fraction with a unit denominator and can be replaced simply by 1 plus 2 to the power of n. And this is the answer to this one. Okay, it's a correct answer. Part B. In part B, we have a somewhat complicated situation, but not too much. So it's 2 to the power of m plus n 2, okay, minus 2 to the power of m divided by 2 to the power of m. So again, this time, however, we are not going to do anything to the bases because they are all the same. The base is 2 in all three powers here. What we can do is to apply a power law which says that a to the power of m plus n is a to the power of m times a to the power of n. We can apply it for this first, or to this first term, and get 2 to the power of m times 2 to the power of 2. So this replaces this first power here, minus 2 to the power of m divided by 2 to the power of m. This leads us to a situation in which we have two terms in the numerator with common factor 2 to the power of m, which can be factored out. So it's 2 to the power of m times 2 to the power of 2 minus 1. Because here this one is 1 times present, just it can be, well, we can add number 1 here like this, and when we take 2 to the power of m out, well, what is left is just 1. This number 1 here, divided by 2 to the power of m, which is present also 1 times, like this. Then you see that this is a common factor between numerator and denominator, so we can cancel out 2 to the power of m and get the answer. 2 to the power of 2 is just 4. 4 minus 1 is 3, so we have 3 over 1, and this should be simply 3. Okay, so it's the answer to part B. In part C, we have 2 to the power of m plus 3 plus 2 to the power of m divided by 9. So this is the exercise, the problem we have to solve. So how to do it? Well, actually use the same strategy. Number 2 can be taken as a base. When we use this law here, we can replace 2 to the power of m plus 3 by 2 to the power of m times 2 to the power of 3 plus 2 to the power of m, and imagine there is times 1 included there, divided by 9. Now we can take the common factor out. It's 2 to the power of m factored out, and what is left is, from the first term we get 2 to the power of 3 plus, and from the second term we have 1 divided by 9, like that. Now it equals 2 to the power of m times, we have 2 to the power of 3, which is 2 times 2 times 2, it's 8, plus 1 is 9, so we have 9 divided by 9. This time the common factor between the numerator and denominator is just number 9, so we can cancel it out. So there is 1 times 9 here in the denominator. So you end up with 2 to the power of m divided by 1, which is simply 2 to the power of m. And this should be the answer.